Here's a problem looking at arc length. Okay, so an ant is walking around the edge of a dinner plate with diameter 10 inches. So normally we think about radius. The radius would be 5 inches. If the ant walks 6 inches around the edge, so typically our default is to start at the positive x-axis and go counterclockwise, 6 inches around the edge. What is the angle formed between the radius ending at where the ant began, that's this radius, and the radius ending where the ant got to? What's that angle? So if we're looking at the classic arc length formula, if you're in degrees, you got pi over 180 times the angle times the radius. Now we happen to know the radius is 5, and we happen to know that the arc length is 6 inches. So let's see. If we had 180 over 5, we could sort of reduce the, 5 over 180, we could reduce this. What is that? That is 36. So then we could multiply 36 times 6. That would be 216. 216 equals pi theta, or theta equals 216 over pi. What is that? 216 divided by pi. That's about 68.75 degrees. Okay, now what if you wanted to do that in radians? That's the degree measure. Well, radians are actually set up to do the arc length more easily. The arc length in radians is just the angle times the radius. So the arc length is 6, the radius is 5, and so theta would be equal to 6/5, right? That's like 1.2 radians. And that's really part of the reason radians is set up that way.